Ano na? Anong ano na? Physics. Kasi yung mga materials. Ano? Lo! Patay! Aray ko!
Today, we'll explore experiment number 23, cut short, which demonstrates conservation of energy. To illustrate the principle of conservation of energy with a pendulum, these are the following materials we only use and substitute, such as rod, steel ball, clamp, and string. We attach the alternative clamp using cardboard to the middle stand. We hang the ball on the string. We tie a horizontal string between the two outer stands. The horizontal string is about 2/3 as high as the pendulum clamp. We attach a rod to the middle stand so it touches the pendulum string when the ball is straight down. Before we release, we make a prediction if we pull the ball up and release it while the pendulum string hits the rod at the level of the horizontal string. Will the ball swing? A. The ball will go higher than the horizontal string. B. The ball will go just as high as the horizontal string. Or letter C. The ball will not go as high as the horizontal string. Our prediction is C. Now, we release the pendulum and our observation found that the ball will not go as high as the horizontal string, hence making our prediction correct. Next, we move the rod higher than the horizontal string and do the test again. Our prediction here, the ball will go higher than horizontal string. And for the observation, it is also the same as our prediction given. The ball will go higher than the horizontal string. Now we move the rod lower than the horizontal string and try again. Our prediction here, the ball will not go as high as the horizontal string. But for the observation, again, it is also the same as our prediction given here. The ball will not go as high as the horizontal string. Question 1. Explain your observations in terms of potential and kinetic energy and the conservation of energy. When we lift the ball, it has potential energy because of its height. When we let it go, the ball moves faster and that is kinetic energy. At the bottom, almost all energy is kinetic. As it swings up, kinetic energy changes back to potential. The total energy stays the same, but some energy can change to heat or sound when the rod or string touches. That is why it may not reach the same height. Question 2. Is there an upper limit on how high the rod can be? If so, explain why you think there are limits. Yes, if the rod is too high, it will stop the string earlier and block the swing. The ball cannot pass the rod, so it will not reach the other side's normal height. The rod can only be as high as the place where the string can still swing past it. Question 3. Is there a lower limit on how low the rod can be? If so, explain why you think there are limits. Yes, if the rod is lower than 2/5 the distance between the lowest position of the ball and the height of the string, the ball does a loop-the-loop, or when a ball travels in a vertical circle, so it goes upside down and comes back around. This activity shows energy moves between height, potential, and motion, kinetic. The rod shows how touching changes motion and makes energy change to heat. If we want better results, we can make the setup steady and repeat each test more times.